Friends, welcome to this session. Today we are going to discuss one more form of line which is known as intercept form, and we will discuss what are the conditions of parallel and perpendicular lines. So let us start our discussion on this tally top. Last session we had different forms. Let us add one more form in it, which we call it intercept form of the line. Intercept form of the line. That is, suppose we are given a line in this fashion. There is a line. Let us label it by L. This value OA is called intercept of the line on x-axis, which is small a. OB is said to be intercept of the line on y-axis. Let us call it B. And if we are given A and B, what will be the equation of the line? The equation of this line is, it is very simple. X divided by the intercept plus y divided by the intercept on y-axis is equal to 1. So this is the form, this is the equation of a line which make intercepts A and B respectively on the axis. X upon A plus y upon B is equal to 1. Let us see now an example in which how one can apply these different forms to solve the given sum. Let us say find slope ને ગુજરાતીમાં આપણે ઢાળ કહીએ છીએ, slope and intercept slope and intercepts of the line x cos alpha plus y sin alpha plus a constant k equal to 0. Here we are given an equation of the line. The requirement is what will be the slope of the line and what are its intercepts on the axis, that is x-axis and y-axis respectively. So let us begin with the given equation x cos alpha plus y sin alpha plus k equal to 0 and change y as a subject from this equation. આ સમીકરણમાંથી y ને આપણે કર્તા બનાવીએ. y sin alpha will be minus x cos alpha minus k. Let us divide by sin alpha. So we have y is equal to minus x cos alpha by sin alpha minus k divided by sin alpha. On further simplification, let us find it as under. It is y is equal to minus cos by sin cot alpha into x, okay, minus k 1 upon sin equal cosec alpha. So this equation is of the form y is equal to mx plus c. Y is equal to mx plus c. So compare our equation with the standard equation y is equal to mx plus c. I find that m is equal to minus cot alpha. That will be the slope of the line which was required. Further, we proceed ahead and find the intercepts of this line on the axis. For that, let us rewrite our equation x cos alpha y sin alpha is equal to minus k. Okay. Next, let us divide this equation by minus k. On division by minus k, I find that x cos alpha minus k plus y sin alpha minus k is 1. Hence, it is x upon minus k upon cos alpha. Fine. Plus y divided by minus k upon sin alpha. That is equal to 1. Now we are carrying out this exercise, this simplification, because I know that the equation of the line having intercepts A and B on the axis is this one. So we will simplify and we will compare with the standard equation, which is intercept form of the line, and we will conclude the values of A and B as under. X divided by, it is minus k sec alpha plus y divided by minus k cosec alpha, as 1 upon sine it is, which is equal to 1. So, now compare this equation with the standard equation. I find that the value of A is as under. The value of A is found to be minus k sec alpha, B minus k cosec alpha. So the intercepts of the line on the axis are like this. So this is the way to find the slope and the intercepts of the line on the axis. Further, let us see two lines are intersecting. Two lines are intersecting. How to find the angle between the intersecting lines? બે રેખાઓ એકબીજાને છેદતી હોય તો તેમની વચ્ચેનો કોણ કેવી રીતે મેળવવો એની વાત કરીએ. So I take the axis, the intersection of the lines as under, intersection of the lines as under, like this. There is one line, there is one more. Let me call it L1 and let this line be L2. Suppose the slope of the line L2 is M2 and slope of line number 1 is M1. That is, we are having two equations of the lines, and from those two equations I can always find slope number 1, slope number 2. Suppose the acute angle between the lines is alpha. આ બંને રેખાઓના જે છેદી રહી છે એમની વચ્ચેનો લઘુકોણ બને છે આલ્ફા. તો આલ્ફાની ગણતરી માટે to calculate alpha, the formula for the same is tan alpha is equal to m1 minus m2 upon 1 plus m1 into m2. As I said, we are calculating acute angle. This value might be negative. And if it is negative, alpha will be greater than 90, that is obtuse. તો આપણને ગુરુકોણ મળે. પણ આપણે જાણીએ છીએ કે આપણે લઘુકોણની જ ગણતરી કરવી છે, તો મોડ્યુલસ સાઇન મૂકી દઈએ. મોડ્યુલસ ઓફ. This is the formula for finding angle between two lines. What we are interested is as under two particular cases. Number 1, if the lines are parallel, જો રેખાઓ સમાંતર હોય તો શું થાય? રેખાઓ પરસ્પર સમાંતર હોય તો તેમની વચ્ચેનો ખૂણો અર્થાત આલ્ફાની કિંમત 0 થાય, because the lines are parallel. Alpha is 0, tan alpha is 0, because tan 0 is 0. So this formula takes the form as under something A upon B is equal to 0. Numerator by denominator equal to 0. On cross multiplication, we find that this numerator is 0. That is, m1 minus m2 is equal to 0. And that gave us the important result about the slopes of the line for parallel lines. So we conclude that if line number 1 is parallel to line number 2, then m1 is equal to m2, and if m1 is equal to m2, the lines are parallel. So we highlight this result as it is very important as far as the problem solving question is concerned. So parallel lines are there. We have case number 2. We discussed about parallel lines. Next case. If lines are perpendicular, then what will happen? If the lines are perpendicular. If two lines are perpendicular, angle between those two lines is 90 degree or pi by 2. And we know that tan 90 or tan pi by 2 is sin 90 to cos 90, undefined, infinity. And let us substitute this value in the equation angle between two lines, that is tan alpha is equal to mod m1 minus m2 upon 1 plus m1 m2, and taking cross multiplication, we find that m1 into m2 is minus 1. So we conclude this result in this fashion, that if two lines are perpendicular to each other, the multiplication of their slopes equal minus 1. So in mathematical language, I will write this result as under L1 perpendicular to L2 implies m1 into m2 minus 1 and vice versa. So we highlight this result with the note that if two lines are perpendicular to each other, slope of any one is minus 1 upon the other. So that was the conditions for parallel and perpendicular lines. Let us further see how to solve the examples using this idea. We check it as under. For what value of k, for what value of k, the lines equations of the lines are as under 3x plus 4ky, k is unknown, plus 8 equal to 0, and 3ky minus 9x plus 10 equal to 0. 10 equal to 0. What is that value of k for which these two lines, for what value of k the lines are perpendicular, so this is the question. For what k the lines are perpendicular? Let us label line number 1. Let us say that its equation 3x 4ky plus 8 equal to 0 is our line number 1. Second, L2, its equation 3ky minus 9x plus 10 equal to 0. And let us calculate the slope M1 and M2 of the lines. First I consider line number 1. Change y as a subject. We rewrite 4ky equal minus 3x minus 8. So, therefore, y is equal to minus 3 upon 4k minus 8 divided by 4k. Second line, it is 3ky equal to 9x minus 10, y equal to 9 by 3k x minus 10 by 3k. So what we have done over here, that we have represented the lines in the standard form y is equal to mx plus c. And let us compare these last two equations with y is equal to mx plus c. On comparison, we will find that the slope of the line number 1, that is m1, is found to be minus 3 upon 4k, and that of second line, as it was 9 upon 3k, result in 3 by k. But we are given that line number 1, that is, two given lines are perpendicular to each other. L1 perpendicular L2. When the lines are perpendicular, we know that multiplication of their slopes equal minus 1. We do that minus 3 upon 4k times 3 upon k will be minus 1. Cross multiplication, etc., I find that 4k square equal to 9. That give me k square equal to 9 by 4, and that finally lead to required k. When we take square root, apply plus minus, that give me this value. K is nothing but plus minus 3 by 2. So this is the way of using parallel or perpendicular lines concept in solving the equations. Further, we find few more examples on the same topic, like this one. Find equations of lines number 1 parallel, number 2 perpendicular to the line, x by 2 plus y upon 3 is equal to 1. The required line number 1 is parallel to this one. Required line number 2 is perpendicular to this one. And it is, that is required one, is passing through the point minus 2, minus 3. So now we want to solve this example. First of all, consider the given line, which is x by 2, y upon 3 is 1. Take LCM and simplify. That lead to 3x plus 2y is equal to 6. The resulting equation. Let us find the slope of the line. As usual, change y as a subject, divide by 2, minus 3 by 2x, and compare this with the standard equation y is equal to mx plus c. I find that slope of the given line is minus 3 by 2. We have just seen if two lines are parallel, their slopes equate. So, slope of line parallel to given line parallel to given line, let us call it m dash, then that will equal to m as they are parallel, and the value is minus 3 by 2. So first we are calculating the equation of the parallel line. For the equation of a parallel line, you need slope, it is there, and the point through which it passes. I have got the slope. Now I will be writing the equation as under. Equation of the required line is y minus y1 equal to m dash x minus x1, where x1 y1 is given to us the point through which the required line passes, minus 2 minus 3. The value of the slope is also there, namely minus 3 by 2. So let us substitute y minus y1 equal to slope x minus x1 let us simplify 2 into, so it is 2y plus 6, 2y plus 6 is equal to, it is minus 3x is equal to minus 3x minus 6. Take all the terms on the left hand side. I get 2y plus 6 plus 3x plus 6 vanish. Give me 3x plus 2y plus 12 equal to 0. this is the line which is parallel to the given line and it passes through the given point. Okay. Further, we are asked to find the line which is perpendicular. Further, if m dash is the slope of line perpendicular to the given line, then we know that m dash into m must be minus 1 as they are perpendicular. That is, m dash is equal to minus 1 upon m, or minus 1 upon minus 3 by 2 lead to 2 by 3. So now we have slope. The point remains same. Now we have to write the equation of the perpendicular line. Hence, equation of perpendicular line is y minus y1 equal to slope of the perpendicular line, which we just calculated. It was 2 by 3 x minus x1. We substitute the values as the point is minus to minus 3. We substitute y1 equal to minus 3 minus 2 by 3 x minus 2, and on simplification multiply by 3. It is 3y plus 9 equal to 2x plus 4. Bring all the terms on one side, say right hand side. It is 2x plus 4 minus 3y minus 9 equal to 0. That is 2x minus 3y minus 5 is equal to 0. So we note one thing over here, the way in which we solved this example, that lead us to conclude the following note. Number 1, any line parallel to the line any line parallel to the line ax plus by plus c equal to 0 is nothing but, take care, first two terms remain same. The only difference will be in the constant, that is ax plus by remains same, only that constant will change. Let us say it is k equal to 0. This is the general equation of any line parallel to the given line. Further, I find that any line, that is our note number 2, any line perpendicular to the given line, which is ax plus by plus c equal to 0, is as under. Interchange the coefficients of x and y, mean bx ay. Interchange the coefficients and change the sign in between, plus a constant equal to 0. That constant can be any number. Before I conclude, let us find one more example on the discussion. The x-intercept of a line is given to us. The line is kx minus y equal to 3k minus 6. This is the line given to us where k is unknown and the x-intercept of that line is given to be 15. The question is, what will be k? That is, find k. We rewrite the given equation in the standard form. The given equation is kx minus y equal to 3k minus 6. This is what we are given. Let us divide the equation of the line by this quantity, that is 3k minus 6. I find that kx by 3k minus 6 minus y by 3k minus 6 in this way is 1. Let us make a little rearrangement, as we are going to compare it with x upon a plus y upon b equal to 1. This standard equation. So that gave us idea of x. It is 3k minus 6 divided by k. We are just rewriting it in the form x upon a. Let me keep the plus sign, and we supply that minus 1 to 3k minus 6 equal to 1. So on comparing this line with the standard one, I find that the x-intercept, that is A, is found to be 3k minus 6 divided by k. This is x-intercept, and it is given to us as 15. So let us simplify, and we find that this what will be the value of k. Let us further carry out the simplification. 3k minus 6 equal to 15k. Okay. So something 15 minus 3 etc. gave us 12k. So k is equal to minus 6 by 12 as a result. So that was the value of k provided the lines are, or the x-intercept of the line is 15. Further, we find one more. Find equation of median CF of a triangle ABC where the coordinates of A are given as 1, 3, B has 5, 7, C minus 1, 9. So I want the equation of the median. Let us have a rough sketch how the line and etc. look like. Say this is A, B, and that vertex is C. A has 1, 3, B 5, 7, minus 1, 9. Find the midpoint of AB. Midpoint of AB. Let me call it F. F. What we require is equation of this line, which is median CF. Considering the concept of a midpoint, it is nothing but the average of the coordinates. That is, the coordinates of this point F are 1 plus 5 by 2, 3 plus 7 by 2, 6 by 2, 10 by 2, 3 divided 3, 5. So C has -1, 9. The midpoint of AB, namely F, has 3, 5. The equation of line CF, which is nothing but the median, madhyagaj, it is a line through 2 points. So let us use the idea of 2 points equal to 0. X, Y, 1, 1, 1, -1, 9, 3, 5. And we simplify this equation to finally find the equation of the median CF. We proceed. X into 9 minus 5 minus y into -1 minus 3 plus 1 into -5 minus 27 is equal to 0. Result in 4x, 4y, -5 minus 27 result 32. As it can be seen that it is divisible by 4. On dividing the equation by 4, finally I find that 8 is equal to 0. So that was the equation of the median CF required. Thank you friends for attending this session.